Good evening, everyone. This is June 2016, Unit 5 of IAL Chemistry. The first question, what are the oxidation states of vanadium in the ion as shown? So in VO2 with the charge 2 plus, with the charge plus 1. So when we write the oxidation states for VO2 with the charge plus 1, each oxygen is minus 1, so 2 oxygen should be minus 4 because the net charge is plus 1, so vanadium should be plus 5. So either C will be answer or D. When we check the second one, VO2 with a charge 2 plus, each oxygen is minus 2, so the net charge is plus 2, so vanadium should be plus 4. So the third one, VO3 with a charge of minus 1, each oxygen is minus 1, 3 oxygen will be minus 6. So vanadium here should be plus 5, so that the net charge will be minus 1. So it matches with option D. In the next question, the conditions for concentration and temperature required for standard electrode potential of hydrogen. So the standard condition that concentration of a hydrogen in the solution should be 1 mole. So either C will be answer, either A will be answer or B will be answer. And then the temperature, it's 25 degrees centigrade or 298 Kelvin. So it will be B. The next question, excess of potassium iodide solution is added to acidified potassium manganate. The reaction has taken place. The iodine produced is titrated with sodium thiosulfate and a burette. The mole ratio of MnO4 ion to S2O3 ion. So how we can work out the mole ratio? So we need a combined equation from 1 and 2 which does not include iodine. So how we remove iodine? If I multiply, here we have 5 iodine, so if I multiply this equation by 5, so this will turn into 10, this will be 5, this will be 5, and this will be 10. So when we add the two equation, iodine will cancel with iodine, so we are left with, I'm not writing the full equation, to get the mole ratio MnO4 with the charge minus 1 and S2O3 with the charge minus 2. The simplest ratio, because the ratio is 2 is to 10, or the simplest ratio will be 1 is to 5. So B will be the right answer. The titration is carried out without a starch indicator, the color change, because we have iodine molecule and it turned into iodide ion. So iodine molecule is pale yellow or light yellow and iodide ion is colorless without a starch. So the color change is from yellow to colorless. D is the right answer. The next question, methanol can be used as a fuel in a fuel cell. The half equation for the reaction in an acidic conditions are there. The standard electrode potential for the first one is 0.02. The standard electrode potential for the second half, if the fuel cell voltage is 1.21. So electrode potential, the reduction electrode potential minus oxidation potential is equals to electrode potential of a cell. So we know in a fuel cell we have alcohol. Alcohol will be oxidized. So the oxidation, the electrode potential for this one is given 0.02. So oxidation is given, that is 0.02. Reduction electrode potential we don't know, the second half equation. And for cell, that is 1.21. So this is minus 0.02, it will move other side. So the reduction potential or the second half equation, it will be 1.21 plus 0.02, that's equal to 1.23. So C will be the right answer. The half equation for the reaction take place in alkaline condition. The value of the standard electrode potential of a cell in alkaline condition are same as that in acidic. This is because whenever overall equation is same, then the electrode potential is also same. So when we write the total overall equation, combined equation, we get the same result. That's why the electrode potential of a cell in alkaline condition is same as in acidic. So overall reaction is same. That's why they have the same electrode potentials. D is the right answer. What are the shapes of these complexes? The two ligands are attached, so it should be linear. C will be answer, or D. Then platinum, it has a square planar complexes, so C is the right answer. Which can have an isomer, cis, or pass. In an aqueous solution of copper 2 sulfate containing CuH2O bracket 6 ions reacted with solution of other ligand. The most stable complex will produce when water molecule are replaced by, because when EDTA will replace, it will remove all of these water molecules and only one ligand is attached, that is EDTA, and it will produce more particles, so entropy will increase. So more stable complex is formed with EDTA. Because if ammonia is there, it will, the total against that it will exchange, but not the number will remain same thing for chloride. Diamine, it's a bidentate ligand, so it will replace all the 6 molecules by 3, but EDTA, all the 6 molecules are replaced by 1. Zinc hydroxide react with acid to form an ion, and it with alkali form an ion. So it is forming an ion with both acid and alkali. So what it shows zinc hydroxide is an amphoteric. That's why it is reacting both with both acid and alkali. Question 8. Acidified sodium potassium tartrate solution was mixed with hydrogen peroxide in a boiling tube. When pink cobalt 2 chloride solution was added, there was a rapid effervescence, carbon dioxide was produced, and solution turned green. After few seconds of effervescence stopped and the solution turned back pink. So it means it returned back, cobalt was originally +2, it changes oxidation number and returned back to +2. So we have the same cobalt 2 ion before and after. That's why we say that it is acting like a catalyst. And transition element in an aqueous solution are better catalysts. Why? Because they can easily be oxidized and reduced. The structure of aspartame, an artificial sweetener, is given below. The functional groups in a molecule are, so we have C double bonded with O, ester is there. We have C double bonded with O and N, so amide is there. We have C and NH2, so amine is there, and we have a benzene ring, arene is there, and we have C double bonded with OH, carboxylic. So D is the right answer. How many compounds are there which have the benzene ring and the structure formula C6H3? So possible isomers of trinitrobenzene. So what could be the possible isomers? If we draw a benzene ring, NO2, so it can be 1, 2, and 3 trinitro benzene. The second one, when we draw first position, second position, and fourth position, this is 1, 2, and 4, the trinitro benzene. And we can have first position, third position, and fifth position. We have 1, 3, 5 trinitrobenzene. So 3 possible isomers are there. If you want, if you draw any other, you'll find it will come out in one of the categories. So A is the right answer. When amines dissolve in water, they form an alkaline solution. Why? Because amine, they have a lone pair, so which can accept proton easily. C is the right answer. Methyl acrylate has a structure shown. So repeat unit. For this structure, how we can draw? So basically, it is forming addition polymer. So if I draw the monomer first, it will be C double bonded to C, H is there, H, and CH3 is there, and then C double bonded with O, and CH, OCH3, ester is there. So we just break the double bond and form an addition polymer. Put a bracket in N so it matches with B. A mixture of amino acid is best separated and identified. So we can identify these amino acids by a technique known as chromatography. Because in infrared spectroscopy, it can identify the type of bond. Mass spectrometer, they may have same mass or may have different masses, but can not be easily identified. Solvent extraction, we can separate, but solvent extraction normally it is used when the substance are miscible and two different solvents. But here they mention a mixture of amino acids. So most of the amino acids are water soluble. Lysine is an amino acid and structure is shown in a pH 10. So acidic, first normally what happened in normal condition, this is vitreine, this will lose proton and this is accepting proton. This is normal condition. But in acidic condition, what we have more protons, more hydrogen ion. So this will accept hydrogen, as well as there is also another amine group that can also accept hydrogen. So both of them will accept hydrogen. So the possible structure when both groups will accept hydrogen, that's B. How many different peaks due to hydrogen atom would expect in low resolution NMR of 2,2-dimethyl propanol? So propanol aldehyde, and second position we have methyl groups. So these are the same hydrogen environments. That is A, which will have 9 hydrogen, and B will have only 1 hydrogen. So 9:1 is the simplest ratio, and there are 2 hydrogen environments. One of the reason using a steam distillation rather than fraction distillation to separate the liquid from a mixture is because if a liquid decompose or substance decompose below its boiling point, we normally use steam distillation, so that without converting that or without changing the state, we obtain that substance. Otherwise, if you increase the temperature, that substance might decompose. Question 17. Complete combustion of a hydrocarbon, 1.76 grams of carbon dioxide and 0.72 grams of water. What is the molecular formula which is consistent with? So how we can work out, as it is giving 1.76 gram of carbon dioxide. So if we burn, like example, if we burn C4H8 or any of the compound, we can find the mass of carbon, and we can also find the mass of, so mass of carbon is 12 divided by 44, because the ratio of carbon to carbon dioxide, that is 12:44. So if we have 1.76 grams of carbon dioxide, how much carbon will be there? X. So 12 into 1.76, so that's 12 multiplied by 1.76 divided by 44, so it is 0.48. So this contains 0.48 carbon. And what about hydrogen? Because one molecule of water contains 2 hydrogens, so 2:18 is the simplest ratio. How much water is there? 0.72. So this will be X. So 0.72 into 2. It's 0.72 multiplied by 2, and that is divided by 18, which will give 0.08. So we have 0.08 grams of hydrogen. Now we'll find the empirical formula. So carbon and hydrogen, we have 0.048, 0.48 and 0.08. So this will be divided by 12. This will be divided by 1. So 0.48 divided by 12, 0.48 divided by 12, that is equals to 0.04. So this will be 0.04 and this is 0.08. Then we divide by smallest value. The smallest value is 0.04. So we divide by the smallest value, take the simplest ratio. So ratio between carbon and hydrogen is 1:2. So which formula, this empirical formula is CH2, so ratio is 1:2. So which formula is having a simplest ratio 1:2? So C is the right answer. Question 18. Phenylamine can be produced from benzene by reaction sequence below. The mass of phenylamine to 2 decimal place produced by 3.9 gram of benzene. So what is the simplest ratio of benzene is to phenylamine in terms of mass? 78:93. So if 78:93 is the simplest ratio, if we have 3.9 grams of benzene, then we need x grams. So 3.9 multiplied by 93, so it is 3.9 multiplied by 93, and that is divided by 78. So this will make 4.65. So this x will be 4.65. But what we have, the first stage yield is 70% or 0.7 in terms of decimal, and second stage yield is 60%. So the first stage will get only 0.7 and the second stage will get 0.6. So when we multiply this all, it will come out as 1.93, which is approximately equal to 1.95. So A is the right answer. So this was Unit 5 of IAL Chemistry from June 2016.